Hello everybody, we are moving to chapter 8. We're going to end the year with chapter 8 and we're going to start by talking about greatest common factors. So you'll be able to write the prime factorization of numbers and find the greatest common factor of monomials. You'll also be able to define what is prime factorization and what is the greatest common factor. Okay, first of all, what's a factor? A factor is a whole number that is multiplied to find a product. Okay, and then prime, that's a number with exactly two factors, one in itself. So prime factorization means we've done this before, we're going to break the number down saying 6 multiplied to what is 48, and we're going to keep breaking it down until all we have left are prime numbers. So let's start that process. So 6 multiplied to 8 is 48. 6 times 8 is 48. Now we're going to break the 6 apart. Well, 2 multiplied to 3 is 6. Let's break this 8 apart. 2 multiplied to 4 is 8. Lastly, I'm going to break the 4 apart, and that is 2 multiplied to 2. It's important to bring down all your prime numbers. So what I'll do is I'll take this 2, which is prime, and bring it down. And then I'm going to bring down my 3. That's also prime. And I'll bring down this 2 here also. So I end up with 4 2's and a 3. You can write it with an exponent, but for this, today we're going to leave them like this so that it's easier to match up. Alright, let's practice with 35. So what times what is 35? Well, I know that 5 multiplied to 7 is 35, but you know what? That's it. I can't break those apart, so that's my factorization. Now 105. Now it ends in 5, so I know I can divide it by 5. So I'm going to do 5 multiplied to 21. I have to ask myself, can I break up 21? And yes, I can. 21 is 3 multiplied to 7. So bring my prime factors down. I have a 5, a 3, and a 7. It's important to write that in order, least to greatest. That will help us later. So these are my factors of 105. Well, now let's talk about the greatest common factor. So here's how you do it. To find the greatest common factor, do the prime factorization of each pair of numbers, and then find any factors that they have in common. Whatever they have in common, we'll multiply those, and that will give us their greatest common factor. And this is one method. I'll show you another method in the next slide. So if we look at 12, 12 is broken down as 3 times 4, and then 4 is 2 times 2. So the greatest common factors of 12 are 2, 2, and 3. Now the greatest common factors of 16, if you look, that broke down to 4 times 4, but we kept breaking it down and we have 4 2's. Alright, so we have 4 2's that make up 16. Now let's circle what they have in common. Well, they have this in common and they also have this other 2 in common. So if we put those together, 2 times 2 is 4. The greatest common factor between 12 and 16 is 4, and that was one way to do it. So 4 is the biggest number that can divide 12 and 16. Alright, on the last slide I showed you what was called method 1 for finding the greatest common factor. It was prime factorization. This method 2 to find the greatest common factor is we list all of our factors of the numbers. So the factors of 100 are 1 times 100, 2 multiplied to 50, 4 multiplied to 25, and so on. The factors for 60 are 1 times 60, 2 times 30, and so on. And what we're going to do is circle the greatest one. So if I look here, I see that 20 is the biggest number they have in common. Now, you know, they do have this in common, they have other numbers in common, but we want the largest one. So the greatest common factor here is 20. After that, they do not have anything in common. Okay, let's find greatest common factors of these monomials when they have variables involved. The method I'm going to use is list out my factors. So the factors of 9, if I break 9 apart, it's 3 times 3. And then I'm going to list my x's. I have 2 x's. For 15, I'm going to break that apart and do 3 multiplied to 5. And I have 3 x's right here, 3 x's. So I'm going to write all 3 of those. In order to find the greatest common factor, remember what we do. We circle what they have in common. They have this in common, they have a 3 in common, and they have 2 x's in common. So the greatest common factor, the GCF, for these two monomials will be 3 and x squared, because I could take 2 x's from here and I could take 2 x's from here. That's my answer. Alright, let's try the next one. I'm going to take this 10m3 and I'm going to write it underneath, and I'm going to list my factors of both. So I took 50, I did a quick little prime factorization chart, and I did 50 is 5 times 10, and 10 is 2 times 5. So 50 is 2 times 5 times 5. So 2 multiplied to 5 multiplied to 5. I have 1 m, and I have 4 n's. For my 10, I broke that apart to 2 times 5, and for my 3 m's, I wrote them. Now I'm going to circle what we have in common. We have a 2 in common, we have a 5 in common, and we have 1 m, only 1 in common. So we have a 2, a 5, and an m. Now I'm going to multiply those together to get 10m. That's my greatest common factor. And it means I could divide both of these by 10, and I could take 1 m from each, because they each have 1 m to give. Alright, here are the practice problems. Use any method you want. Bring any questions to class next time we meet, and take care.